Hi, everyone. Welcome to our webinar today on injecting security into the agentic development lifecycle, or how do you build security into vibe coding, right? So I think this is our first webinar of the year. Really happy to be here, and I'm hoping that all of you find some value out of today's session. And let's get started. I'm not going to waste too much time getting into a preamble. Let's get started and let's get into the topic. As always, with our webinars, we have a lot of ground to cover, and at the same time we also have demos. So those demos are always going to be something that I feel you'll derive value from. So with that in mind, let's get started, and let me show you. Let's start presenting my screen, and just give me a second here. uh, let's actually start presenting my screen. Just give me a second. I need to switch out of the. Yeah, okay, perfect. All right. So this topic is something that a lot of folks have brought up with me, especially since agentic or AI assisted development has taken over. And this is something that I've seen a lot of people look at with a lot of fear, and to a certain extent, rightfully so, simply because vibe coding has become the default, right? Very in the shortest possible time, you see everybody vibe coding today. Everybody, or vibe coding or AI assisted coding or whatever you want to call it, they're doing that, and that's not something that's likely to stop. It's only likely to accelerate. Even some of the stodgiest companies that have some of the most restrictive security requirements today are vibe coding. So it means that this is not a flash in the pan effect. This is something that is happening across the board. And the idea is, how do you bring some kind of security control and capability into vibe coding? How do you ensure that vibe coding just does not go off the rails and create a ton of security bugs? And it's happened. It continues to happen. It's not that this is an unfounded expectation. Vibe coding does tend to create a lot of security issues. And let's talk about that. Let's talk about ways in which this can be dealt with in a meaningful way, in a way that's comprehensive, and in a way that is nuanced as well. So let's understand all of this, right? So, with this in mind, just an introduction of myself. My name is Abhay. I'm the creator and founder of SecurityReviewAI. I also run an application security consulting company called V45, and many of you might also know me as the creator of AppSec Engineer, our training platform, where you learn secure coding, DevSecOps, cloud security, and so on and so forth. Right? So you have all of those things that I do. So I've been in application security for more than 15, 16 years now. I've done a ton of work in the threat modeling space. That's really what I do most of my day. I also train and speak at multiple events at Black Hat. In fact, this year we're doing a bunch of AI trainings at Black Hat. We're doing some AI training in Black Hat Australia, which is a new thing that's starting in June. So very interesting stuff. One of the other things that I've also done more recently is created a methodology called the PWN ISMS, or as it's also called PWN ISMS, which is a threat categorization technique for AI agents, which helps AI agents do better threat modeling. So that's something that I've done quite a bit of as well. Right. So this is me. I just wanted to share my credentials for those of you who've not heard of me before. Now let's get started and understand some of the things around the topic. Right now, the AI coding thing is not something, like I said. It's not a flash in the pan. It's an effect that's here to stay. Right. According to the 2025 GitHub, these are the stats I found. They're not necessarily the latest stats, because I think 46% is a very low number. It's probably doubled or close to doubled by now. I feel most of the code today is AI generated. A lot of the code is AI generated. Um, 20 million plus developers are using GitHub Copilot alone, as per Microsoft. Now, remember, this is not including Claude Code and Cursor and all of these other open code and all of these other harnesses that allow developers to write code with different models and so on. This is again, 84% of developers now use or plan to use AI coding tools. I see this checks out. It's already happening, and there has been a massive adoption in terms of AI coding. And the thing that should probably worries a lot of product security folks or security teams is that developers literally just accept 88% of code suggestions and generations by the AI IDE, right? So means that 9 times out of 10, pretty much, you're just saying, yeah, that's fine, accept, and you're okaying the code that is generated by AI or your AI agent. So that is something that's happening, and this is a very important thing to think about because there is very little oversight. This tells you that there is very little oversight over the entire over the code that is generated by AI. Right? Developers are not really paying attention. In fact, I would say that most developers don't even know what is being written. They just know that they're describing a functionality and they're making sure that that functionality gets written, and they're doing some tests and we're working on it. Some people, of course, do more, some people do less, but balance of probability, a lot of them don't know what is being written by the AI agent or the AI agent harness, right? So this is something that is happening quite a lot. And the security part of it is not looking great right now as well, right? A lot of AI generated code contains security flaws. I mean, surprise, surprise, it's trained on code written by human beings. Human beings write insecure code, AI writes insecure code. So there is a lot of insecure code that is generated by AI. It's not necessarily secure. A lot of basic mistakes, like things like CSRF issues, SSRF issues, all of this stuff happens quite a lot. XSS, common issue that's happening with AI generated code. So you'll see an increase in the incidents per pull request, 30% change. So I'm sure all of you have seen the AWS stats, the crashes that have happened in with a lot of different cloud providers, with Microsoft, with AWS. A lot of it is being attributed to AI generated code, which I am not surprised by. A lot of them are shipping tons of code and with very little oversight. And because there's very little oversight, that code is likely to fail at places people really don't know much about, right? So that is something that's happening. And the worst part, so insecure. So when you think about AI generating insecure code, that's one part of it. There is also the other part of it, which is the architectural crisis, right? Now, AI doesn't have any kind of a clear understanding of your architectural decisions that you have taken to build an app or when you're building an app, right? It's going to create or it's going to write source files which is based on what it thinks is correct and what, of course, runs and makes sense from a feature completion perspective, right? It doesn't really care about architectural patterns. It suddenly decides to go with a certain type of password hashing format, and with a different functionality might do use something completely different. It is entirely probabilistic. It might use different authentication modes, might use different authorization models, it might use different inconsistent error handling logic. This is stuff that happens a lot. So more than just the secure coding problem, there is also a design security design problem, and this is really the crux of the matter. So there are two problems you're dealing with. One is secure code. You already know this. You kind of have some ways of addressing this, perhaps. But the secure design problem is much, much worse because this goes into blind issues that you probably don't know are ever there. Maybe find it extremely difficult to debug down the road because it's probably 2 months in, you've shipped the 30 new features. Because of that, the it gets much harder for you to actually identify the key source of the problem, which is these architectural mismatches that are generated by your AI agents, right? So this is something that I find a lot of. In fact, I vibe code every day, and I see this happening quite a lot personally, and also the people I speak to, my customers that I work with. This happens quite a lot of. So this is a very common thing. It is a thing that we need to be worried about, right? So, simply because this is expanding. So the number of vulnerabilities that are being generated could be code vulnerabilities, could be design vulnerabilities, could be configuration vulnerabilities are increasing, and the design vulnerabilities make things exponentially worse. You might make a design choice that is terrible. AI might decide to do that, and you just don't know what it's done because, hey, you've gone ahead and approved 9 times out of 10 whatever the agent has done. So this is something that tends to be a serious repeating problem with AI assisted code. Now, let's talk about the way this has impacted the SDLC. Right now, all of this has happened. We know AI assisted code is not something that is some kind of anomaly anymore. That is the default, and that's going to be the dominant default over days to come. Models may improve, their quality of code might do a little bit of improvement, but really this is something that we're dealing with now, and vibe coding is here to stay. Now the SDLC has really become the ADLC, right? Or the agentic development lifecycle. And this is not one of those things that is likely to happen. It's already happened. And in many companies, this is happening rapidly, very fast being adopted, right? So the ADLC is really much faster iterations, right? You have a goal, you write that goal, basically that's your prompt. You might write your goal more or less specifically depending on how you do things. That is generated into a plan and a spec. They are spec driven development, whatever you call it. Agents produce a plan or a spec depending on how you set up the agent to do it. Based on that spec, the agent converts that into a list of to dos, runs those to dos, and basically generates code. And once that code is generated, agents scan it, deploy it, and then of course agents monitor that code as well. So there is an entire series of non-humans getting involved in the SDLC. Earlier, all of this used to be heavily human driven. Just a few months ago, this used to be very human driven, but in a matter of a few months, this has become entirely an agent based process. In many companies, this has really changed the way they ship. Things that used to take a few months or weeks to get shipped now are shipping in a few hours. So this is crazy change of speed. The speed paradigm has completely shifted. Things have gotten much faster. Obviously, when things get much faster, lots of things break also, and that's what has happened, as you've seen from my previous stats before. Now, so this is the ADLC, right? This is the ADLC. And just like any other SDLC, the ADLC also needs its own treatment from a security perspective, right? Now, security, again, this is DevSecOps for agents, if you will, right? What you want is security injection points at different stages of the agentic lifecycle or the ADLC, right? So when the requirements or spec is written before this even makes its way to a prompt, and analyze that from a security perspective. You do your threat model, your security design reviews, come up with a secure design to begin with. When the developer writes prompts into the AI IDE, that is analyzed, a secure by design spec is generated for that. When the code is generated, it is scanned from a security perspective, or there are already some guardrails to ensure that secure code is written right off the bat. When it's deployed, obviously you have some kind of guardrails in terms of infrastructure as code scanning, or in terms of other agents that are scanning the or validate the environment, ensure the configurations of that environment are hardened, and then you can do your automated pen testing. In fact, RSA, if you've been to RSA, if you are in RSA, you'll probably see that the theme of this year is AI or agentic pen testing, and that has also taken off in a big way. We ourselves have a pretty strong agentic pen testing practice where we have our agentic pen tests run a whole bunch of stuff against targets. So this is really powerful. And again, all of these are force multipliers, which ensures that speeds are reached, as well as in this case, security is achieved. So what you really want to do is, just like you had with DevSecOps, you need to create feedback loops for agents, or security based feedback loops for agents. Agents need to be involved in different stages of the cycle, in some cases acting continuously in those stages, so that you can achieve your security goals. Now, a lot of organizations have not woken up to this reality. They are still, you'll see their engineering teams already doing the ADLC with having some basic security stuff, maybe here to a certain extent, but nowhere else. We are still running security like it was written for a manual world, right? We're still doing SAST, we're still doing manual dash, we're still doing, even if it's automated, it's not that automated. You're seeing a lot of manual processes still making its way, even though the way we ship the application has changed completely to become agentic. So this is something we need to address in a very serious way, and we need to have we need to build out some kind of security practice to address this in a serious way. The other thing that I want to talk about here, which may be interesting to some of you, is that the entire security industry seems to be focusing here through here, right? From this part of it to the deployment and monitoring part of it. That's where most of the time and effort is going. When in fact, it should be going into these two stages itself. The reason is, at these speeds, catching security issues from here on out becomes much, much harder, right? Just like it is harder to fix security issues. There was a time, there was an IBM survey done several years ago. I'm talking about 2018 or so, where it said that every stage that a security bug makes its way into the next stage, it becomes that much harder to fix. I don't have the exact numbers, but something like 10x, 100x, whatever. It kind of exponentially increased in difficulty of identifying and fixing it. This Imagine that when in a manual code development world, imagine that in an agentic world where things are shipped at lightning speeds, right? This is a real problem, and unfortunately most of our product security initiatives are still focused on SAST, supply chain, deployment related stuff, pen testing, or even AI pen testing, if you will, or an AI SOC, right? So this is in my view a missed opportunity and a mistake that we are likely to see blow up quite a bit in our faces as days pass, right? So this is something that I'm sure is going to be a problem in days to come. Now, this is something people are taking note of. So this was a statement by Dr. Richard Hahn, who's the CEO of the UK National Cybersecurity Center and NCSC, and he said this in RSA on March 24th, which is, the vibe coding attraction is there. It's very clear. Disrupting manually produced software is consistently vulnerable. So he's mentioned that yes, vibe coding is happening. It's there. It's very much a reality that we have to reckon with. But it is a huge security opportunity. It is not something that we should waste. A lot of times we think that a lot of people I've seen either fall into two buckets, right? One bucket is, vibe coding is just producing a lot of bugs, but we can't do anything, so we'll just stick to what we already know, which is not going to work. And the other is like, vibe coding is, it's not a reality. We don't really care about it. Let's get to it at a certain particular point, which is pretty much the same as one, but it's a slightly different treatment. So you will see that the interventions for this also need to be addressing AI in its core, right? That's really what we need to do, but we're not doing it. We need to take that opportunity. Vibe coding, just like it's given us an opportunity to accelerate code, it also gives us the opportunity to build in security in the same accelerated way. So the idea is that we want to build in security controls where it is accelerated, at the same time invisible, at the same time doing its job and catching things as early and as often as possible, even before, ideally before the code is written, right? So that's really what we want. So SAST. So a lot of people have spent a ton of time and money and effort on SAST. In fact, even the frontier models, your OpenAIs, your Anthropics, are spending a lot of time on code security, right? So they're like, look, you give me, I'll generate a piece of code, I'll scan that piece of code and tell you whether it has bug security issues. It's kind of a, eat your own dog food kind of a thing. SAST is still a big talking point. And I mean, that's fine, fair enough. SAST is a big talking point because you want to be able to scan and validate the code that's being written and ensure that it's free of security issues. But there is a bigger thing to keep in mind. Just because you are producing, let's say you do the best SAST program possible, catches the issues, you fix them, all of that stuff. Does that mean, and a lot of times that's not happening, by the way, and I'm still describing a utopian style situation here. So let's say you do a great job of SAST, you catch everything, you do everything, all of that is done. But let's imagine, does that mean your application is actually secure? I beg to differ that that's the case, because your application, while it may have secure code, it may still not have secure architecture. I told you about this in the beginning of the session, where I said that secure architecture is a completely different animal, simply because the AI, the IDE or the agent doesn't really care about your architecture. It's just going to write code to get the job done. So you need to have not just code, you need to have security design patterns that are formulated before that code is even written. So you have the security design patterns formulated, that is translated into secure code, and that code is what is written, and that code is what is shipped, right? So you really want that chain to be completed in a way that is very it completes the entire circuit. It starts off with building out a threat model, doing so when the developer writes a prompt, the prompt goes into the IDE. As soon as the prompt goes into the IDE, it runs the agent to perform a threat model based on some rules, based on some logic, some skills. All of those things are available, and based on those skills, you have a threat model generated. And based on that threat model, the spec that is generated is a secure by design spec that is generated and then implemented by the AI assisted IDE. So that's really what we want. So that ensures you have at the prompt level itself, analyze security, threat model before the code is generated, pull architectural design patterns. All of that stuff is what you want to do. So you're not creating massive security debt down the road. You're dealing with it in a much more consistent, meaningful, manageable way right at the prompt. And that's really what you want to do, right? That's something that you want to do. So the idea is that you analyze the prompt, do a threat model. In our case, we use a methodology called PWN ISMS. The reason we use PWN ISMS is that it's a full stack threat categorization system that captures threats by product, workload, network, IAM, secrets, monitoring, and supply chain, right? That's one of the best things about PWN ISMS, because you are getting coverage across the stack. A lot of times, when you think of Stride and stuff like that, Stride is good for human beings, but when it comes to agents, you need to be more specific, and PWN ISMS has been created just to be more specific as a more specific methodology, right? So that helps when you're using agents. This threat model generates, based on this threat model, you generate a secure by design spec. This spec is again implemented by your AI assisted IDE that generates secure code as well as secure design. So you have secure code and secure design to account for, not just secure code, which may be caught by a SAST program later, right, after the fact. So that's not what we want. We really want secure code generation and secure design generation, right? That's really what we want to do here. So the PWN ISMS methodology, like I said, is something that we've created, and we've seen a massive capability upgrade because of this, because agents clearly understand what they need to do when it comes to generating threats. And this is very important because you need to quickly identify threats based off of this. And the cool thing with PWN ISMS is that you can use it with Stride. So you can use it with Stride, without Stride. You can use it with any different permutations, combinations you want, generate the threat scenarios, and based on the threat scenarios you generate. And the cool thing with this is that you don't miss out stuff. I'm sure if you have done a threat model, you'll realize that a lot of it just gets, a lot of it vanishes into the ether in terms of monitoring threats, supply chain threats, a lot of them not counted. In fact, some of the stuff that you're seeing today with Team PCP and Shai Hulud and all of that stuff is largely because supply chain threat modeling has not been done properly in a lot of these organizations. So this is something that we need to keep in mind, and that's why this methodology makes a whole lot of sense, especially if you're doing threat modeling with an agent. Right, that's something that you have to think about. So what does this capability look like, right? So what should it be, right? What is it that we want? What is our wish list when it comes to something like this, right? This is something that we want to see, right? One is prompt level threat modeling. Each prompt is because the developer is just going to write a prompt. They don't really. The idea is that the developer should be completely unaware of the actual security piece at all. They should just write a prompt and move on, and that should get implemented securely. That's the challenge here, right? So the prompt itself must be analyzed. You need to have some kind of a central state or some central memory store that pulls architectural patterns, because you want consistency of architecture. You want secure spec generation, so you need to do a quick threat model. generate a secure spec, and of course ensure that that secure spec is implemented. And for auditing and analytics, that secure spec is pushed to a central location, and the decisions that you've taken are pushed to a central location, and it needs to be IDE native and zero friction, which means that the developer should not even know, just like the developer does not know most of the time what decisions are being taken by the IDE, in this case when it comes to AI assisted development. This should also be the same. It should just be an extension of the developer's workflow and nothing more. And that's really one of the things that we've built, right? One of the things that we've built in Security Review is a capability called Vibe Review. And I'm going to show you this very soon. And you'll see how it works. It's really interesting. And I'm going to show you this in an app that I am just building out. So here I'm building out this this payments application, and I have some data from this application stored in Security Review, in the Vibe Review, right? So the idea here is that I, as a developer, should not have any kind of security knowledge, or I don't need any kind of security knowledge. All I have to do is I need to write a prompt, and I want that to get threat modeled. I want that to get converted into a security specification. I want the code to be implemented based on that security specification. And finally, I want those decisions that were implemented, the security that was implemented, pushed into a central location for additional analysis, for additional validation, and so on. Right. So this is an application that does payments, and it has users, owners, billing agents, and all of that stuff, right? So this application is that. So I'm going to write a new functionality. I'm just going to write a new prompt for a piece of functionality that I want to write, which is I want to add capability where only the owner can approve payment requests that come in to the organization, right? So this is a capability that I want to add. Obviously, this capability does have some security related potential to it. So I'm just going to do this. I'm not going to add anything. I'm not going to say that do it this way, do it that way, add this security capability. I'm not going to add anything here. I'm just going to be invisible. I am a developer who knows nothing about the security bit, right? I'm just going to say this. Now, what this is going to do is that it is going to pull down the it's going to read the code first, and then it's going to start pulling down the different capabilities, so that it can first threat model perform a threat model against that capability, generate a specification. So it says, you see this, it says for the implementation I need to set up 2 endpoints. I'll also be able to emit events, and it does a PWN ISMS based threat model. You'll see that the thoughts have that. So it says PWN ISMS threat model. It says all of these things. So it says current problem, blah 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 blah, no approval gate, I need to introduce a 2-step process. All of this has been threat modeled functionality, which has been created as a spec. Right now, this spec is already threat modeled. By the time I have done this, it's already been threat modeled, because it's walked through the threat model itself using certain skills. Based on those skills, it has implemented the more secure spec with all of these things, and then it has written the functionality to include that secure spec right from the get-go, and then it is working on the to-dos as we speak. And finally, it will take this and push this into our central Security Review AI server, where it has the analytics of what was done, who has done it, what are the decisions taken, what is the code implemented. All of that stuff is going to be shown there once it's done, right? So you'll see that it is adding all of this functionality, and very shortly it will also run that threat model and push. I mean, not run, it's already run the threat model. It's going to push the results of that secure specification to a particular endpoint, right? So this is going to be at a particular endpoint. So you see that what are the different threats? It says already these threats have been enumerated. And based on this, only it has generated that spec. So it says IDOR is a threat, business logic replay, reapproving an already succeeded payment. All of these are things that are part of the secure design of this package or this software, right? So you'll see that it's identified all of this stuff. It's identified, and it's also said where there are no new dependencies, no new external calls. It just ignores those categories of threats. And it says that all of this is done. I'm going to push this. So it has actually created this threat model. So you'll see that the threat model is there, the changes made is this, the threats addressed is this, and it's pushing all of these data points, these results, into our security review server, where it can be used by security teams for further analysis. If they want to add additional guardrails, if they want to implement, if they want to add more controls on top of this, if they find something that they need to do for the next pass, they can add that. And you can also get details about which developer did this, what was the violations caught, what was the things that were done. And so you'll see that it's being done here. Very shortly it will be pushed, and once it's pushed, it will essentially have the data very clearly mapped out in security review for central analytics and audit trails, right? So that's something you have. So every single security decision that's being taken in the IDE is not only threat modeled, or every single prompt is not only threat modeled, it's also pushed to the central server so that it can get validated and is there for audit trails and additional analysis, additional guardrails if you want to do. So it's just pushing that through MCP, and this takes a little bit of time. This is what it looks like, right? So this is it tells you that these were the threats that were mitigated consistently. It tells you which the categories are, and then you'll actually see the details of what was already implemented, right? So recently, I just added this before the webinar started. I wanted a payment audit trail update, so you'll see that feature. So I wanted to add structured logging to the payment system. So you see that this was the threats that were identified based on the quick threat model that were created. And of course, the best practices performed and identified, and the secure code snippets that were implemented based off of that plan, right? So it's very clear. You have all the decisions taken. It's pulling from a central architectural data set that it has these decisions already loaded into. So you're not having the issue of people implementing weird architectural patterns that don't really make much sense, right? So it is validated based on a central idea of an architecture, and then it ensures that those security decisions are made based on those architectural patterns, right? So that's what it's doing. It's just pushing all of these things into security review. So the idea here is that the developer does not have to change any of their approaches to doing anything, right? They don't need to change anything. Their workflow is not affected. They're just writing prompts. Those prompts are they're getting addressed, and the prompts have a security analysis built into it. It's secure by design right from the get-go, and they're doing nothing. They're not changing anything. You're not adding any additional cognitive overhead to the developer. It's really simple that all of this is just pushed through, and because it has sub agents, you can just start building out other stuff as you need to. This uses the sub agents scenario here. So this is how vibe coding can become a force multiplier from a security perspective, rather than you having a situation where vibe coding is seen as a liability or a security way to create security debt. It can become that, by the way. Vibe coding can have that effect. But if you think about these kind of things, or leveraging security in the agentic development lifecycle, it will be a huge win, because you're able to get this done in a much more meaningful way without impacting the developers, at the same time ensuring that you are shipping well designed applications, which is not just well designed from a functionality perspective but a security perspective, and you're shipping secure code. So all of these objectives are being met in tandem. So that's one of the benefits of this approach. This is one approach. Of course, you have several others, but this is one approach that we believe is going to be a very important way to lock down things, especially when you want to scale threat modeling amongst your developer community. So that's something that I wanted to talk about. I'm happy to take any questions if anyone has them. Or if there are no questions, you can log off. In the meantime, let me just check if it pushed. Yeah, it's updating the profile. Right. So, all right. I guess there are no questions. With that, thank you. We've come to the end of this session. This session is going to be recorded and shared, of course. So please, and if you have any questions about any of this, please reach out to me. I'm happy to answer your questions on LinkedIn, wherever. Thank you so much for watching, and I hope you found value. And thank you so much, and have a good rest of your day.